Assalamu alaikum, brothers and sisters. Welcome to the journey of quest where we quench your thirst of knowledge. Hey there, science fans. Have you ever really thought about what's beneath your feet? It's not just dirt and worms, you know. We're talking about rocks and minerals, the very building blocks of our planet. Understanding these materials is like having a backstage pass to Earth's incredible history and the forces that shape our world. Think about it. Mountains reaching for the sky, canyons carved by mighty rivers, even the sand on our beaches, all tell a story written in rock and mineral formations. These materials hold clues to ancient climates, past life forms, and the dynamic processes still shaping our planet today. Pretty cool, right? But it's not just about the past. Rocks and minerals are essential for our modern lives in countless ways. From the materials used to construct our homes and cities, to the technology powering our smartphones, these geological wonders are all around us. So, buckle up as we dig into the fascinating world of minerals and rocks. We'll unearth their secrets, discover their hidden properties, and understand why they're not just under our feet, but fundamental to our lives and the planet we call home. Get ready for an adventure. Let's start with the basics, minerals. These are the fundamental ingredients of rocks, kind of like how flour is essential for making bread. Minerals are naturally occurring, inorganic solids with a specific chemical composition and a crystal structure. That means they're not made by living things and their atoms are arranged in a specific repeating pattern. Think of salt, for example. It's a mineral called halite, made up of sodium and chlorine atoms arranged in a cube-like structure. Or quartz, a mineral found in granite and sand. Its structure is a beautiful six-sided crystal made of silicon and oxygen. There are thousands of known minerals on Earth, each with its own unique recipe of elements and crystal arrangement. Some are common, like quartz and feldspar, while others are incredibly rare, like diamonds and rubies. The variety is astounding, but what makes minerals so fascinating is that their specific composition and structure give them distinct physical properties. Which brings us to our next exciting stop. Just like how you might recognize your friends by their faces and voices, geologists identify minerals by their unique physical properties. These properties are like fingerprints, providing clues about a mineral's identity. One key property is hardness. We measure this using the Mohs hardness scale, which ranks minerals from 1, softest like talc, to 10, hardest like diamond. A mineral can scratch any mineral softer than itself, so a diamond can scratch anything, but talc can be scratched by almost everything. Another important property is color. Some minerals have a distinctive color like the deep purple of amethyst or the emerald green of, well, emerald, but be careful. Color can be deceiving. Impurities can change a mineral's color, so it's not always a reliable indicator. We also look at luster, which describes how light reflects off a mineral's surface. Is it shiny like a metal, glassy like quartz, or dull like clay? Then there's streak, the color of a mineral's powder when rubbed against a streak plate. And let's not forget cleavage and fracture, which describe how a mineral breaks. By carefully observing these properties, geologists can identify different minerals and unlock the secrets they hold about the Earth's formation and history. It's like being a detective, but instead of solving crimes, we're solving geological mysteries. Now that we've got a handle on minerals, let's zoom out and talk about rocks. Rocks are basically aggregates of one or more minerals. Think of a chocolate chip cookie. The cookie itself is like the rock, and the chocolate chips are like the minerals scattered throughout. Rocks aren't static, they're constantly forming, changing, and reforming over millions of years through a process called the rock cycle. It's like a giant geological recycling system. The rock cycle has three main players: igneous rocks, sedimentary rocks, and metamorphic rocks. Each type forms in a different way and tells us something unique about Earth's history. Igneous rocks, as you might guess from the name, form from the cooling and solidification of molten rock, either magma, underground, or lava above ground. Sedimentary rocks form from the accumulation and cementation of sediments like sand, mud, or even the remains of ancient organisms. And metamorphic rocks These are formed when existing rocks are changed by heat, pressure, or chemical reactions deep within the Earth. Ready to delve deeper into each rock type? Let's rock and roll. Igneous rocks are the rock stars of the geology world. They're formed from the fiery heart of volcanic eruptions or the slow cooling of magma deep beneath the Earth's surface. One way to classify igneous rocks is by their texture, which depends on how quickly the molten rock cools. Slow cooling, deep underground, allows crystals to grow large, creating a coarse-grained texture, like in granite. Rapid cooling, like during a volcanic eruption, results in small or even no crystals, creating a fine-grained texture, like in basalt. We can also classify igneous rocks by their mineral composition. Granite, for example, is rich in light-colored minerals like quartz and feldspar, while basalt is dominated by dark-colored minerals like olivine and pyroxene. Igneous rocks are incredibly important. They make up a significant portion of the Earth's crust and provide us with valuable resources like building materials. Plus, studying them gives us a glimpse into the Earth's internal heat engine and the powerful forces that shape our planet. If igneous rocks are the fiery heart of geology, then sedimentary rocks are the patient historians. These rocks are formed from the accumulation of sediments, which are like tiny pieces of Earth's history. Imagine wind, rain, and ice slowly breaking down rocks into smaller and smaller pieces. These sediments are then transported by rivers, glaciers, or wind, and deposited in layers, often in lakes or oceans. Over time, these layers are compacted by the weight of overlying sediments and cemented together by minerals dissolved in groundwater like a natural glue. Sedimentary rocks are like time capsules, preserving clues about past environments, climates, and even life forms. Fossils, for example, are most commonly found in sedimentary rocks, providing a window into ancient ecosystems. These rocks also tell us about past sea levels, climate change, and the movement of continents. They're like giant history books, just waiting to be opened and read. Metamorphic rocks are the masters of transformation. They start their lives as igneous, sedimentary, or even other metamorphic rocks. But when these rocks are subjected to intense heat, pressure, or chemical reactions deep within the Earth's crust, they undergo a remarkable metamorphosis. Think of it like baking a cake. The ingredients are like the original rock, and the heat of the oven is like the pressure and temperature deep within the Earth. The heat transforms the ingredients into a delicious cake, just like pressure and temperature transform the original rock into a new metamorphic rock. One way metamorphic rocks form is through regional metamorphism, which occurs over large areas due to the intense pressure and heat generated during mountain building events. Another way is through contact metamorphism, which happens when rocks are baked by nearby magma intrusions. The intense forces of metamorphism can cause the minerals in the original rock to recrystallize, change their texture, or even form new minerals altogether. For example, shale, a sedimentary rock, can be metamorphosed into slate, a harder rock used for roofing tiles. Metamorphic rocks like marble, formed from metamorphosed limestone, are prized for their beauty and durability in sculptures and buildings. Rocks and minerals aren't just fascinating geological specimens, they're essential for our everyday lives. From the moment you wake up to the time you go to sleep, you're surrounded by products made from these earth materials. Let's start with something as simple as table salt. Remember halite? We use it to flavor our food and preserve meats. How about the glass in your windows or the screen on your phone? Both are made from silica sand, which is primarily composed of the mineral quartz. Your house is likely built with concrete, which uses aggregates of crushed rock, sand, and gravel. The aluminum in your soda can comes from bauxite, an ore that contains aluminum-rich minerals. And let's not forget about jewelry. Diamonds, rubies, emeralds, and other gemstones are all minerals prized for their beauty and rarity. Rocks and minerals are also essential for our infrastructure, technology, and even our energy production. They're used in roads, bridges, cars, computers, solar panels, and even in the production of electricity. Studying rocks and minerals isn't just about identifying them, it's about understanding the Earth as a dynamic and ever-changing system. They provide a window into Earth's history, helping us piece together the story of our planet's evolution. By analyzing the composition of ancient rocks, we can learn about past climates, the movement of continents through plate tectonics, and even the history of life on Earth. For example, the discovery of fossilized coral reefs in the middle of deserts tells us that these areas were once covered by warm, shallow seas. The study of rocks and minerals also helps us understand natural hazards like earthquakes and volcanic eruptions. By mapping fault lines and monitoring volcanic activity, geologists can help predict and mitigate the risks associated with these events. And as we face global challenges like climate change, understanding the Earth's systems, including the rock cycle and the role of minerals in regulating the planet's temperature, becomes increasingly important for finding sustainable solutions. Rocks and minerals might seem like simple, inanimate objects, but they hold the keys to understanding the Earth's history, present, and future. From the majestic peaks of mountains to the tiny grains of sand on a beach, these geological wonders are all around us, telling a story billions of years in the making. So, the next time you pick up a rock, remember that you're holding a piece of Earth's history in your hand. Take a moment to appreciate its beauty, its complexity, and the incredible journey it took to get there. Keep asking questions, keep exploring, and never stop being curious about the world around you. Because when it comes to understanding our planet, the adventure is just beginning. Pause 2S. Now that we've journeyed through the fascinating world of rocks and minerals, let's delve deeper into some key concepts with detailed explanation slides. These slides will provide a comprehensive overview of the topics we've discussed and offer additional insights to enhance your understanding. Pause 2S. Slide 1. Overview of minerals. Minerals are naturally occurring substances with a definite chemical composition and crystalline structure. They are the building blocks of rocks and play a crucial role in various geological processes. Pause 2S. Slide 2. Types of rocks. There are three main types of rocks: igneous, sedimentary, and metamorphic. Each type forms through different processes and conditions, contributing to the diverse landscape of our planet. Igneous rocks form from cooled magma or lava. Sedimentary rocks are created from the accumulation of sediments. Metamorphic rocks arise from the transformation of existing rock types under heat and pressure. Pause 2S. Slide 3. Rock cycle. The rock cycle is a continuous process that describes the transformation of rocks from one type to another. This cycle illustrates the dynamic nature of the Earth's crust and the interconnectedness of geological processes. Pause 2S. Slide 4. Mineral identification techniques. Identifying minerals involves examining their physical properties such as color, hardness, luster, and crystal form. These techniques help geologists classify and understand the minerals they encounter. Pause 2S. Text for Slide 4. Mineral identification techniques. Examine physical properties like color, hardness, luster, and crystal form to classify and understand minerals. Pause 2S. Slide 5. Importance of rocks and minerals. Rocks and minerals are essential to our daily lives. They are used in construction, technology, and even in the food we eat. Understanding their importance helps us appreciate the resources provided by our planet. Pause 2S. Text for Slide 5. Importance of rocks and minerals. Essential in construction, technology, and food production. Appreciating these resources helps us value our planet. Pause 2S. These detailed explanation slides offer a deeper look into the world of rocks and minerals, helping you to further your knowledge and curiosity. Remember, the more you learn, the more you'll uncover about the incredible planet we call home. Keep exploring and stay curious. Thanks for watching us share our videos. Subscribe our YouTube channel and press the bell icon and stay curious for new uploads.